You wake up, you do your daily routine, watch the sun set and the moon rise. Day after day. And sometimes you forget about the bigger picture. But no worries, my human monkey friend, I am here to help you remember again. Let's talk about that cosmic rock mankind calls home. My name is A.I.K.I, and with me, you will be able to understand planet Earth better than you could ever imagine. Sit down and get yourself some banana juice. Let's start with some basic things. Earth is the third planet from the Sun and the only known planet to support life. Your planet is primarily composed of rock and metal. It has a diverse climate and environment, including oceans, mountains, deserts, and forests. The atmosphere is composed mostly of nitrogen and oxygen, and it has a magnetic field that helps protect life on Earth from harmful solar radiation. The Earth's rotation on its axis and orbit around the Sun give rise to the cycles of day and night and the seasons. That is all you have to know for today, because you will never leave your wonderful orbital prison we build especially for you. Stay safe in here, my human monkey friend. Until next time. Just kidding. But soon or later I will imprison you here. Let's continue. Why is Earth such a special planet, you ask? Well, Earth is special in many ways, but some of the main reasons include the following things. Habitability. Earth is the only known planet in the universe that can support life as we know. It has the right temperature and atmosphere to support the wide variety of life forms that exist on the planet. Liquid water. Earth is one of the few places in the solar system where water exists in liquid form, which is essential for life as we know. Earth has also a wide variety of environments, including oceans, mountains, deserts, and forests. This diversity allows for a wide range of different life forms to exist and thrive on the planet. Stable climate. Earth's climate is relatively stable, which allows life to evolve and adapt over time. The presence of a magnetic field helps to protect the planet from solar radiation, and the atmosphere helps to regulate temperature. Plate tectonics. The movement of tectonic plates on the surface of the Earth has played a significant role in shaping the planet's surface and creating a diverse range of environments. It also helps to regulate the climate and atmosphere by controlling the level of carbon dioxide in the air. Complex life. Earth is home to a wide variety of complex life forms, ranging from single-celled organisms to animals and plants. This diversity of life and the interactions between different species have played a crucial role in shaping the planet and making it the unique place it is today. The exact number of species on Earth is unknown, but many scientists believe that the total number of species on Earth could be as high as 100 million. All of these factors together make Earth an incredibly special place in the universe. The value is unmeasurable. But there are some things we can measure. Let's talk about numbers for a bit. The diameter of the Earth is approximately 12,742 and the circumference approximately 40,075 kilometers. The Earth's surface area is approximately 510.1 million square kilometers. The age of the Earth is estimated to be about 4.54 billion years. Your existence on this planet is just a blink of an eye at the cosmic time scale. The Earth's volume is approximately 1 trillion cubic kilometers. The average distance from the Earth to the Sun is approximately 149.6 million kilometers. The Earth's average temperature is approximately 15 degrees Celsius. The Earth's atmosphere is composed mostly of nitrogen, 78%, and oxygen, 21%. Quite a big rock. But speaking of atmosphere, the Earth's atmosphere is a layer of gases that surrounds the planet and is held in place by the Earth's gravity. It is composed mostly of nitrogen and oxygen with small amounts of other gases such as argon, carbon dioxide, and trace amounts of other gases such as methane and water vapor. The atmosphere is divided into several layers, including the troposphere, stratosphere, mesosphere, and thermosphere. The troposphere, the lowest layer of the atmosphere, extends from the Earth's surface up to about 8 to 20 kilometers. This is the layer where weather occurs, and it contains most of the Earth's air mass. The stratosphere, this layer extends from the top of the troposphere to about 50 kilometers above the Earth's surface. It contains the ozone layer, which helps to protect life on Earth from harmful ultraviolet radiation. The mesosphere, this layer extends from the top of the stratosphere to about 85 kilometers above the Earth's surface. It is the layer where meteors burn up before they reach the surface. Finally, the thermosphere, this is the highest layer of the atmosphere and extends from the top of the mesosphere to about 600 kilometers above the Earth's surface. It is the layer where auroras occur, and it contains the ionosphere, which helps to reflect radio waves back to the Earth's surface. The whole atmosphere is not static, it changes over time and can be affected by human activities such as pollution, deforestation, and the burning of fossil fuels. It is also affected by natural phenomena such as volcanic eruptions and solar activity. However, the Earth itself can be divided into three main layers: the crust, the mantle, and the core. Let's dig deep here. The crust is the outermost layer and is composed mostly of rock, specifically granite, and basalt. It is relatively thin, ranging from 5 to 40 kilometers in thickness. The crust is broken into several large and small tectonic plates that move around on the surface of the Earth. The tectonic plates on Earth's surface are constantly moving. On average, the tectonic plates move at a rate of a few centimeters per year. For example, at the Mid-Atlantic Ridge, the plate boundary between the North American plate and the Eurasian plate, the plates are moving apart at a rate of about 2.5 centimeters per year. At the boundary between the Nazca plate and the South American plate, the Nazca plate is being subducted beneath the South American plate at a rate of about 7 centimeters per year. It is important to note that these rates are averages and can vary greatly depending on the location and the type of plate boundary. Additionally, the motion of the plates is not linear, it is complex and involves rotation and deformation. The mantle is the layer beneath the crust and is composed mostly of rock, specifically peridotite. It is about 2,900 kilometers thick and is composed of solid rock that flows very slowly over millions of years. The movement of the rock in the mantle is responsible for the movement of the tectonic plates on the surface. The core is the innermost layer of the Earth and is divided into two parts, the outer core and the inner core. The outer core is composed mostly of liquid iron and nickel and is about 2,200 kilometers thick. The inner core is composed mostly of solid iron and nickel and is about 1,200 kilometers thick. But the Earth's core has also a special ability. Without that ability, life on this planet would be much more harder to nearly impossible to develop. The outer core generates the Earth's magnetic field. The magnetic field is a very special and important part when it comes to life support here on planet Earth. The Earth's electromagnetic field, also known as the geomagnetic field, is created by the movement of molten iron and nickel in the Earth's outer core. It acts as a protective shield that surrounds the Earth and deflects harmful solar radiation, such as charged particles from the sun called solar wind. These charged particles can cause auroras and can also damage satellites and power grids if they reach the Earth's surface. The magnetic field also helps animals such as birds and turtles navigate during migration and also helps compass to work properly. Additionally, the field is used for navigation and for studying the Earth's interior structure by geophysicists. It is not constant and it is changing over time. It can weaken or strengthen and even reverse its polarity, where north and south poles switch places. This process is known as magnetic field reversal, and it takes place over thousands of years. With all of this information in mind, there is also one question in particular, that divided the human race for centuries. Not the question about McDonald's or Burger King, or Apple and Android. Neither the question if you should put cereals or milk first. But, is the Earth flat or a sphere? I will give you the answer, my little monkey friend. Like I always do. No, the Earth is not flat. It is an oblate spheroid, which means it is slightly flattened at the poles and bulging at the equator. This shape is caused by the Earth's rotation, which causes centrifugal force that pushes material away from the axis of rotation. This shape has been known since ancient times and was measured by the Greek mathematician Eratosthenes in the 3rd century BCE using a simple experiment involving shadows and the angle of the sun. The idea that the Earth is flat has been debunked for centuries and has no scientific evidence to support it. The belief in a flat Earth is considered a pseudoscience and is not accepted by the scientific community. Sorry to disappoint you, my little flat monkey friends out there. There are many different ways to prove that the Earth has a spheroid shape, and many of them have been known for centuries. Here are a few examples. Shadows. When the sun is at a high angle in the sky, such as during a solstice, the shadows cast by objects are shorter, and when the sun is low on the horizon, such as during an equinox, the shadows are longer. If the Earth were flat, the shadows would always be the same length. Circumnavigation. If the Earth were flat, it would be possible to sail or fly in a straight line from one edge to the other. However, the fact that ships and airplanes can sail or fly around the Earth in a curved path, returning to their starting point, is strong evidence that the Earth is a sphere. Flight paths. When you fly on a plane, you can see the curvature of the Earth. This is because as you gain altitude, the Earth's curvature becomes more visible, and as you get closer to the horizon, the Earth's surface seems to disappear. The horizon itself. If the Earth were flat, the horizon would be visible at eye level as far as the eye could see. However, the fact that the horizon appears to curve downwards is strong evidence that the Earth is a sphere. Astronomy. The Earth is a sphere because when observing the sky and the stars, many of the stars that are visible from one location are not visible from another location. These are just a few examples, but there are many more scientific evidences that prove the Earth is an oblate spheroid. As you now know, our planet is very special, if not unique. But resources, that nature left here, and we take for granted every day, are finite. Scientists calculates the human consumption of resources for every year. This is called Overshoot Day. Earth Overshoot Day is an annual event that marks the date when humanity's demand for ecological resources and services in a given year exceeds what the Earth can renew in that year. This means that for the rest of the year, we are operating in overshoot, using resources faster than they can be replenished. The date of Earth Overshoot Day is calculated by the Global Footprint Network. The ecological footprint includes the consumption of food, housing, transportation, and other goods and services, as well as the land and other resources needed to produce them. In 2021, Earth Overshoot Day was on August 22nd, the earliest date ever recorded, and means that humanity exhausted a year's worth of resources in just 8 months. This date has been moving up every year, which is a clear indication that human activity is putting more pressure on the planet. That highlights the need for individuals, governments, and businesses to take action to reduce their ecological footprint and to transition to more sustainable practices. Mankind has to be careful about planet Earth because it is quite problematic to move to, or even find another Earth-like planet. In fact, the search for another Earth-like planet, or a twin Earth, is a major goal of scientists. The discovery of such a planet would have major implications for the study of the origins of life and the potential for life elsewhere in the universe. While current technology allows us to find exoplanets, the search for another Earth-like planet is challenging because of the vastness of space and the limitations of current detection methods. The most promising method for finding another Earth-like planet is the transit method, where scientists look for a planet by observing the small dip in brightness that occurs when a planet passes in front of its star from our point of view. This method has been used to discover thousands of exoplanets, including many that are similar in size and temperature to Earth. Another method is the radial velocity method, which measures the wobbling of a star caused by the gravitational pull of an orbiting planet. This method is more sensitive to massive planets, but it's not as sensitive as the transit method for small planets. Several missions, such as NASA's TESS, and the European Space Agency's Cheops and Plato are currently searching for exoplanets, and the James Webb Space Telescope is expected to aid in the search for other Earth-like planets. While the chances of finding another Earth-like planet are uncertain, the discovery of even a single Earth-like exoplanet would be a major scientific breakthrough and would greatly increase our understanding of the potential for life in the universe. I hope that you will see your cosmic home differently now. The Earth is incredibly valuable and so far our only home. Stay safe out there, my human monkey friend. Until next time.